Bismillahirrahmanirrahim. Today we are going to discuss a worldwide environmental problem called smog with reference to environmental chemistry. Here we will look into the depth and cover how it is formed, which factors initiate smog, and how they can control and what has done on an international level. Before going into the details about smoke, it is important to know about the standards of clean air. An air quality index or AQI is used by the government agencies to communicate to the public how polluted the air currently is and how polluted it is forecast to become. Public health risks increase as the air quality index rises. Particulate matter 2.5 readings are often included in air quality reports from environmental authorities and companies. So, it is in turn important to know about the particulate matter 2.5. This table gives a ready reckoner of air quality index. The green color shows particulate matter from 0 to 50, which means the community live in a healthy environment. Other color regions show different particulate matter values and ultimately the properties of air quality. Particulate matter 2.5 refers to the atmospheric particulate matter that have a diameter of less than 2.5 micrometer, which is about 3% the diameter of a human hair. Particulate matter 2.5 means particles in this category are so small that they can only be detected with an electron microscope. They are even smaller than their counterpart, particulate matter 10, which are particles that are 10 micrometers or less and are also called fine particles. Fine particles can come from various sources. They include power plants, motor vehicles, airplanes, residential wood burning, forest fire, agricultural burning, volcanic eruption, and dust storms. Some are emitted directly into the atmosphere, while others are formed when gases and particles interact with one another in the atmosphere. This picture represents the previous discussion efficiently. It shows a well-established comparison of particulate matter 2.5 and particulate matter 10 with the hair. Moreover, gaseous sulfur dioxide emitted from the power plants reacts with oxygen and water droplets in the air to form sulfuric acid as a secondary particle. Smoke is a kind of air pollution originally named for the mixture of smoke and fog in the air. This kind of a visible air pollution is composed of nitrogen oxides, sulfur oxides, ozone, smoke, and other particulate. Classic smoke results from large amount of coal burning in an area and is caused by a mixture of smoke, volatile organic compound, sulfur dioxide, and oxides of nitrogen. The main sources of these precursors are pollutants released directly into the air by gasoline and diesel-run vehicles and industrial plants. At least two distinct types of smoke are recognized. Number 1, sulfurous smoke. Number 2, photochemical smoke. Sulfurous smoke, which is also called London smoke, results from a high concentrations of sulfur oxides in the air and is caused by the use of sulfur-bearing fossil fuels, particularly coal combustion emission, vehicular emission, and industrial emission. This type of smoke is aggravated by dampness and high concentration of suspended particulate matter in the air. 19th and 20th century, London was particularly well known for this type of air pollution. The Great Smoke of 1952 was identified as the cause of over 4,000 deaths in London. In the 1950s, a new type of smoke known as photochemical smoke was introduced. Photochemical smoke is also known as Los Angeles smoke, it occurs predominantly in the urban areas and have large number of automobiles. It tends to occur more often in summer because we have the most intense sunlight in this season. It is a mixture of pollutants that are formed when nitrogen oxides and volatile organic compounds undergo photochemical reactions in the presence of sunlight in the lower atmosphere, creating a brown haze over cities. The highly toxic ozone gas arises from the reaction of nitrogen oxide with hydrocarbon vapors in the presence of sunlight. And some of the nitrogen dioxide is produced by the photochemical reaction of nitrogen oxide. Surface level ozone concentrations are considered unhealthy if they exceed 70 parts per billion for 8 hours or longer. The resulting smoke causes a light brownish coloration of the atmosphere, reduced visibility, plant damage, irritation of the eyes, and respiratory distress. Now, let's have a look at the biological consequences of smoke. Number 1. Coughing and irritation of the eyes, chest, nose, and throat. High smoke level can irritate the respiratory system, leading to coughing. These effects generally last for only a few days after exposure, but the particles in the smoke can continue to damage the lungs even after the irritation disappears. Number 2. Aggravation of asthma. Asthma conditions are worsened by smoke and can trigger asthma attacks. Number 3. Breathing difficulties and lungs damage. Bronchitis, pneumonia, and emphysema are some of the lung conditions linked to the effect of smoke as it damages the lining of the lungs. Number 4. Premature deaths. World Health Organization report indicated that cumulative exposure to smoke heightens the chances of premature death from cancer and respiratory diseases. Thousands of premature deaths in the United States, Europe, and Asian countries are linked to inhalation of smoke particles. Such chemical particles include benzene, formaldehyde, and butadiene, which are all carcinogenic. Number 5. Birth defects and underweight babies. Smoke is highly linked to birth defects. Spina bifida, a condition depicting malformation of the spinal column, underdevelopment, or the absence of the part of the brain, are birth defects associated with smoke exposure. Furthermore, studies suggest that even as low as the 5 microgram exposure to smoke particulate matter can result in the risk of underweight babies at delivery. Number 6. The risk of developing rickets. Heavy smoke that lasts for prolonged periods block UV rays from reaching the Earth's surface. This results in low production of vitamin D, leading to rickets due to impaired metabolism of calcium and phosphorus in the bone marrow. Number 7. Risk of road and air traffic. Smoke interferes with natural visibility and irritates the eyes. On this basis, it may prevent the driver or flight controller from reading important signs or signals, thereby increasing the probability of a road accident or even plane crash. Number 8. Effect on plants. Smoke inhibits the growth of plants and can lead to extensive damage to crops, trees, and vegetation. When crops and vegetables such as wheat, soybean, tomato, peanuts, and cotton are exposed to smoke, it interferes with their ability to fight infections, thus increasing susceptibility to diseases. Let's look at the remarkable solutions for smoke. Number 1. Renewable energy sources. Renewable energy source helps in the reduction of emission from power generating plants that heavily depend on fossil fuel. In other words, the use of renewable energy not only reduces the environmental impact but also trims down the presence of smoke causing pollutant in the air. Number 2, reducing and managing vehicular and industrial emissions. Vehicles and industries constitute the largest contributor of smoke-forming pollutants. The best way to reduce smoke is to follow maintaining and managing protocol for vehicles and industrial plants and the management of gaseous emission from cars and industries. Now the next is the use of eco-friendly consumer products. The use of household products that have high levels of volatile organic compounds should be completely avoided. These products not only release hazardous material into the atmosphere but also emit particulate matter that reacts in the presence of sunlight to form ground-level ozone. The use of eco-friendly consumer products such as eco-friendly paints, paper, spray, solvents, and plastics therefore provide a basis for addressing smoke pollution. Next is increasing energy efficiency and conserving energy. Increasing energy efficiency and at the same time conserving energy leads to reduced gaseous emissions in the atmosphere that often results in the formation of smoke. A capable and productive energy management system can go a long way in reducing smoke causing pollutants in the air such as nitrogen and sulfur oxides. This is the most important segment of entire discussion that the Environmental Protection Department of Punjab has a smoke policy. The Environmental Protection Department has installed air quality monitors in major cities of Punjab including Lahore, Gujranwala, Multan and Faisalabad. They also monitor air quality and pollution from industrial units and brick kilns. Strict action is being taken against polluters. Any polluting unit is sealed and fined until the necessary apparatus which can tackle air pollution is installed. The government is now introducing zigzag technology which is more efficient and reduce fossil fuel consumption by up to 20%.
Air pollution consists of chemicals or particles in the atmosphere that pose serious health and environmental threats. But what causes air pollution and what does it mean for our planet? Some air pollution comes from natural sources like volcanic eruptions, wildfires, or allergens. But most air pollution results from human activities such as energy use and agriculture. There are different types of human-made air pollution. When we burn fossil fuels to produce energy, they release greenhouse gases into the air. These emissions, such as carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap heat from the sun in Earth's atmosphere, leading to a rise in global temperatures. This creates a cycle where air pollution contributes to climate change, and climate change creates higher temperatures. In turn, higher temperatures intensify some types of air pollution. For example, climate change increases smog because it forms in the presence of high heat and increased levels of ultraviolet radiation. More frequent extreme weather, such as flooding, contributes to damp conditions and therefore to a rise in mold. Warmer weather also leads to longer pollen seasons and therefore more pollen production. Smog is a type of air pollution that reduces visibility and has serious health effects. Smog can be divided into two categories: sulfurous and photochemical. Sulfurous smog is made up of chemical compounds called sulfur oxides. It occurs when burning sulfur-bearing fossil fuels such as coal. Photochemical smog, also called ground-level ozone, is a result of the reaction between sunlight, nitrogen oxides, and volatile organic compounds. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. Volatile organic compounds are released from gasoline, paints, and many cleaning solvents. Smog not only creates a brown haze that reduces visibility, but also harms plants, irritates the eyes, and causes respiratory distress. Another category of air pollution is toxic pollutants. These are chemicals such as mercury, lead, dioxins, and benzene that are released during gas or coal combustion, waste incineration, or burning of gasoline. In addition to adverse environmental effects, toxic air pollution can cause serious health problems such as cancer, reproductive complications, and birth defects. While air pollution has many consequences for our planet, there are solutions. We can limit toxic pollutants, smog, and greenhouse gases by decreasing the use of fossil fuels, such as in transportation, manufacturing, and electricity generation. Reducing air pollution not only contributes to a cleaner environment and better human health, but can also slow the rate of global warming.